All right, guys, so thanks for having me. My name is Pat Alwell. I'm a solutions engineer with Hortonworks. And today I'm going to talk about how to wrangle the Internet of Things, okay? So how many of us have heard of like Minify? By raise of hands. Okay. How many of us deal, Minify, Apache Minify. How many of us deal with streaming applications at all? Okay, cool, so a few of us, okay. I'm going to do my best to kind of work through this because we have a gauge in the audience, so just bear with me. So when I talk to customers, or our customers specifically, the biggest problem they're having is actually moving data, right? And when we're talking about moving data, we're moving data from point A to point B. And HDF has two components in it for managing data flows. And one of them is going to be Apache Minify, and the other one's going to be Apache Minify. So today I'm going to show you a very simple example, but unfortunately it doesn't work. But the demo I had was I have the Minify agent installed on my Raspberry Pi that is going to be pushing raw data. So it's pushing temperature and humidity data from the actual Raspberry Pi. And then I'm using site-to-site communication through Minify that's kind of prepackaged into the solution. And I'm pushing it to a regional infrastructure, which is going to be my laptop. But I'll also show you how to push it actually to core infrastructure. And so both the regional infrastructure and the core infrastructure are going to be using Minify to actually consume the data via site-to-site, okay? But I think I need to define a few things first before I get into that. So HDF is composed of 3 layers, okay? And nothing in HDF, in my opinion, when I wrote this slide, kind of makes sense in light of flow-based programming, which begs the question, what is flow-based programming? It's essentially a paradigm or an extraction, right, that says that information packets, your data that's coming in, okay? Then you're going to have transformations. So you're going to have processors that transform the data. And then you're going to have a common set of connections. So some way that you can agnostically move this data from one location to the next, okay? And so within HDF, we're going to have flow management, we're going to have administration, and we're going to have streaming. So I'll go in through all of these kind of tidbits. But for the main part of the demonstration that I want to show, I'm going to actually show flow management. And real quick, just to cover some terminology, because I might regurgitate some of the stuff as I'm doing it. We're going to be talking about flow files. So the flow files are actually going to be the unit of data that is going to be moving through Minify. And a flow file is very similar to HTTP data in the sense that you have your header or your metadata about the file or your attribute, and then you have your actual physical content that's going to be moving through the actual system. The next thing that you're going to have is that kind of black box in flow-based programming, and that's going to be your processor. So what do you actually want to do with this data? Do you want to normalize it? Do you want to transform it? Do you want to deliver it to S3? Do you want to deliver it to Azure Blob? Do you want to deliver it to a database, right? Those are things that you're going to be doing within the context of a processor. Next, you're going to have a connection. So that's going to be the route between 2 transformations. And you can dynamically queue the priorities of the actual payloads that are going through there. And then finally, last but not least, is the processor group. So when we get to it, I'll show you Minify as a graphical user interface, but it's effectively a very convenient way to package together your flows and have a logical tenet so you understand which flow is resulting to which kind of business logic or group or development process that I'm working on, right? It's just a logical way to encapsulate my flow. So like I've already been explaining, HDF, I kind of wanted to define this as well. So flow management is going to be one piece, and I'll get into that next. The next is going to be stream processing. So we support both Kafka and Storm, and then enterprise services. So we'll talk about kind of how the enterprise services time into a more or less a streaming context. But long story short, we have Schema Registry. We have Minify Registry, so it's a convenient way to actually persist your flows into a GitHub, a Git repository. And then we have Embari and Apache Ranger. So I'll get into that stuff. But in a nutshell, this is going to be HDF. And again, how do we manage flows? So we have Minify and Minify. So the way I like to think about it is Minify is going to be a convenient graphical user interface that supports that notion of flow-based programming. And this sounds trivial, but the way that you would normally do this, and I'll show you guys this code, is you build a Python application or a C application, and you'd have your socket library, and you'd be communicating to whatever kind of protocol you want, and it's a bunch of code, and it gets messy, and it's kind of a hassle. But moreover, when you're building that application, you don't you can't have an understanding of what's going on because it's a process that's running in the background, as opposed to actually having this kind of visual command and control. So I can understand if my processor is getting backed up. I can drag and drop processors onto the canvas. But moreover, when NiFi was originally developed, it was developed by the NSA. And it was developed by the NSA to actually support kind of real-time transactions. And the reason was they wanted somebody who doesn't have development skills to be able to come in and kind of manage flows. And so this visual command and control, kind of the core tenet of NiFi, makes that brilliant, in my opinion. It makes it absolutely brilliant when you go to build flows. And just some examples. So when you go into actual NiFi and you go to drop a processor, it gives you an option, and you have about 260 options. So 200 plus processors, and I'll show you some examples later on. But the examples I have here that I see a lot of customers is they're trying to aggregate logs from different sources. So they'll have an agent running, or they'll have a process running on a remote source that'll grab the logs and push it into a data lake for analysis. So some regex might happen, right? If you have Apache logs, you might have to conduct some regex on it. The regex will happen within NiFi, and then there'll be a processor to put it into HDFS. So that is going to be the block storage that supports Hadoop. Or I could put it into S3, like an object storage, and then point a computational engine at S3 and load the data and do my analytics, what I need to do. So here's further of an example, right? So I have all my kind of connections on the left. I have my services. So within Hadoop or big data, or even technology generally, you have the notion of services. So things like Kafka as a service, Hive as a service, right? Spark as a service, so if anybody's used Spark. And then obviously Amazon Kinesis, right? So all these things kind of can tie together out of the box with NiFi, which makes the overall application development process a lot simpler. Because as an application developer, if I'm interacting with the cloud, if anybody is a cloud developer here, I have what's known as an SDK, or software development kit, right? I have a whole litany of libraries that I'm going to use to build applications that are going to interact with objects in the cloud. And so this just makes it a lot more convenient. Another feature that I think is extremely important when we're talking about streaming applications or data management in general is provenance and lineage. And why does that matter? Again, if I'm doing this within the context of the way a developer would typically do it, I don't have a sense of how my data is being transformed over time. And I don't have a way to track the lineage, more or less, right? So one of the great features out of the box is the notion of having more or less an audit, where I can go back and I can look at my data and see how it's been transformed over time. And I'll show you that as well when we get into the demonstration. And also something that's great, and I note this out to our competitors. A lot of our competitors don't have this feature, but most of the streaming platforms today only have what's known as first in or first out priority. So that means my first record in is going to be the first record out, or it's LIFO. So it means the last record that I'm reading into my kind of flow is going to be the first one in, right, and subsequently. So the great thing about NiFi is it supports both FIFO and LIFO, but it supports these other kind of queue priorities as well. And if you need to, you can develop your own custom priority, right, whatever that might be. Back pressure. So back pressure is also extremely important because I don't understand, depending on the context of what I'm trying to do. If I'm a developer and I'm developing an application, I might not understand the latency of my consumer, right? So I have something producing data, it's being emitted in, and let's say I need sub-second latency, but let's say the consumer can't keep up, so it's getting backlogged. The beautiful thing about NiFi is you can actually see that, both in real time and from a development perspective, that a queue starts turning red and it's saying to the developer that, hey, my processor that I have here, in this case it's update attribute, it's being overwhelmed. You need to go check out what's going on with the actual processor. Maybe it's not keeping up with the payload, or something else is wrong. Maybe there's an error in your code or something else. So that's also brilliant when you actually go to build these real-time streaming applications as a developer. It just makes it a lot more convenient to understand what's going on with your flow, and moreover to maintain your flow, right? Because when we go to stick this stuff into production, I want a way to be able to actually alter this stuff in real time when I'm viewing the application. And then again, last but not least, latency versus throughput. So if I have a particular use case where I want sub-second latency, I have that option. If I have another particular use case where latency is not really that important, I need higher throughput, so I need to push through more information, I also have that option as well. You're not going to find a lot of this stuff out of the box with a lot of the other kind of development features that you have in streaming. And so last but not least, Minify, which is an embeddable agent or embeddable process that you're going to place on the edge device. And we have two flavors. So we have Java, and it's obviously Java, it's going to run within the context of a JVM, so it's going to require JRE 1.8. But we also have C++ version, right? So that's targeted for more resource-constrained environments. And you guys have a copy of this deck, but afterwards, what I want you to do is kind of check out both of these links. I have links for sandboxes as well. It's one thing for me to stand up here and give you guys kind of a conversation. It's another thing to get your hands dirty. And as you get your hands dirty, you'll start to understand more or less how these things interact with the overall ecosystem that we provide, right? But so there's two versions, right? Java and C++. Okay, and getting down to it, so nitty-gritty of this small little application I built today. Unfortunately, due to firewall restrictions, I can't actually stream data from my Raspberry Pi that I have over there via site-to-site, but I'll show you hypothetically how I would do that. I built another script within Minify that's going to mock the data, but more or less what I was doing is I have an application. It's going to read from my GPIO headers, right? So I have headers on my actual device that is collecting binary data from an external source, it being a humidity and temperature sensor. I'm going to stream that using Minify. I'm going to dump that into NiFi, and then after I have it into NiFi, I'm going to conduct some transformations, and I'm going to persist it into my local file system. You can also persist into other things. I'll show you some of the other options you have as well, like S3 or HDFS. And then I'm also going to put it into Solar. And the reason I'm going to put it into Solar is a search database or search engine. It's typically not used for this circumstances. You might use something else to visualize the data. But historically speaking, it's just very convenient to build applications in Solar because it has out-of-the-box features to graphically represent what you've put in there, right? So I'll show you that as well. I'm going to show you the actual dashboard. It's a version of Kabana. It's Banana. If anybody here has worked in analytics for a long time, you might have heard Kabana, but it's going to be Banana. So you'll actually see the information streaming into the dashboard. So without further ado, I'm going to go ahead and go into that, show you guys a demo. Okay. So here I have kind of my canvas, right, that I've developed. And if I were going to do this, if I were going to stick something into Minify, I'd first have to build the application, right? So what I have here is an application that I have shimmed from SunFounders, so I don't want to take it from them, but SunFounders has out-of-the-box applications that they provide when you actually buy sensors for the Raspberry Pi. And I've reauthored it a tiny bit to make it simpler to kind of ingest the data. But more or less what we're doing is we're grabbing the humidity and the temperature. I'm assigning an SID just so I can understand the device. If I have multiple devices, I might have different IDs for my device. I'm applying a date time. I'm converting the temperature to actual Fahrenheit. I'm from Carlsbad, California, so I just had the location as Carlsbad. And then a zip code and device. And then as you can see here, Python's brilliant because it comes with, or it doesn't come with, but you can have a library called simple JSON. It'll actually do the JSON conversion for you, so you don't have to worry about encoding. If anybody's actually worked with JSON, it's kind of a nightmare to decode it when you're reading it from a high-level API, so that's why I did that. But more or less, this is my application, right? So this would be on my Raspberry Pi, and I'd have a directory on my Raspberry Pi. I don't know if I have it here, but similar to, let me see if I have it. Oh, I might. So this is, as you can see, this is my Raspberry Pi. So there's a directory on it. Here it is here. So I've created effectively a bash script that's going to run this file here, and that is going to go into my Minify flow. So if we look, I have a flow here. And so what I'm doing is I'm executing that script, and we can come in here and configure this, and we see there's like these lists in the properties of macro. And that macro that I'm giving it, that command, is saying, hey, when you run, I want you to actually run that bash script, right, that bash file. What I've done here is actually given it a processing group. So this processing group was supposed to come back to my computer. You can see the host address. I'm using HTTP. And it's going to go to this, effectively this REST endpoint, right, which is going to be at the starting point of my NiFi flow. But let me show you something real fast as well. So this right here, right, this is going to hold our script. This is going to push it site to site back to NiFi. Effectively, what I'm going to do to create my Minify flow is I'm going to take this and I'm going to download it as a template. So I'd actually create a template. I come and I create my template. And if we look, I already have a template. So pi to local. So all I did was download an XML version of that actual flow, okay? And then what I'm going to do is there is a bootstrap process that we can run from the command line. Let me see if I have it here. Might be in my notes. No. Okay. But there's a bootstrap process that you would run that would transform that XML file into a YAML file. And then what I'm going to do with that YAML file is I'm going to secure copy it to my device. So I would actually secure copy it to my Raspberry Pi. And there's a command I would run that knows for a fact where that config file lives. And it will boot up a sequence of processing and understanding that, okay, for this particular process, this particular flow, I want to run this script, and I want to push it site to site to this end address. Okay, so this is, if I actually had Minify running on my edge device, it would be pushing things to that port. So if I come back here, I'll show you the port that I would be listening on. So you have this notion of an input port that we would drag onto the console. Now Minify needs to know the name of this as well, and it also needs to know where that port actually exists. And if you look, we have our host name up here, 8080/Nify. So it would be hypothetically delivering it to here, okay? Now if I blow this up a tiny bit, we can see that there's information already queued. So I had been streaming it before. But this is where the lineage and provenance comes into play, right? So it's not making much sense right now, but if I list this queue, I can see all the records that were streaming in. The time they were streamed in, the queue duration, the file size, the bytes. And if I look at it and I view it, I can actually see my temperature data, right? So that was literally what was kind of passed from that Raspberry Pi. So I know that's my record. And now, as a software developer, I can start logically thinking, okay, what do I want to do to this JSON? Okay, well, what's the schema that I need for my downstream consumers? Okay. So moving right along. So what I can do here is, this is a special processor that I've dragged into the canvas. What I wanted to do was one of two things, right? So one was put it in the Solar. It's going to be for graphical visualizing it. The other one is going to be for actually taking the records, putting it into a file, and building almost like a historical ledger of all my transactions from my edge device. Okay, so that historical record, this is what I'm doing right now. So I'm merging all the contents, and I'm putting 50 records into one file. That's what I'm doing in this processor. So if I turn this on, we can see that over those 5,000 records, it generated about 127 flow files. Sorry, not records, flow files, right? Because we have those terms. So if we look in here, actually look at the lineage, right? List queue. You're going to see 50 records in each flow file now, because that's effectively what I told Nify to do. And there you go, 50 records. Right? So you can imagine at scale this going to more records, but for the sake of simplicity, I put them all into one kind of file. Afterwards, what I'm doing here is I don't want to just dump the raw data. So those attributes are going to be the metadata about the file. So something else that's great about Nify is it has what's known as Nify expression language. So it's a supported language that you have that you can use within the context of your processors to manipulate various aspects of the flow files, right? In this case, I am manipulating the actual attributes. I'm renaming the file Raspberry Pi, and I'm going to append a timestamp. So I understand where my records are sequentially on disk, right? It's just a logical way to kind of organize that. So I'm going to press play on that as well, and we'll see the data kind of flow through. And as you can see, it was successful. And then ultimately, what I'm going to do is I'm going to put it somewhere. So I have a directory, and just to show you that I'm not faking it, I'll go to my directory on my terminal. I clear my, and I'm in temp. We can see there is no directory called temperature data, but this processor is going to create it for us. We're going to dump those files in there. So let's turn that on. Oh. Okay, so I have a kind of a limit on the number of files I'm allowed to put in there, but as you can see, it still wrote it. Right, so I said only put 10 files in there. I don't want my computer running out of disk space. But you can see that there's a temperature data that I just wrote there. We can go in there and we can cat one of these. There's all my records. Right, so literally in a few simple steps, I've taken raw data from a sensor. I've more or less hypothetically air quotes, normalized it and stuck it into a directory. So now what we can do as well, so that's kind of one kind of aspect to this, right, that I wanted to show you guys today. Is taking something from an edge device and sticking it in a directory. I can also stick it in other locations as well, right? So if I drag another process into here, let's say I want to stick it into Kafka. So a lot of teams are using Kafka. I can come and type Kafka, and I can do a publish Kafka and add. So now I can create Kafka topics on the fly with a processor. Okay, so next I want to show you is the visualization aspect. So let me actually start Solar. Solar's running. If we go to Solar, we'll see that I have my data. Let me do a quick query. And here's all my data, right? My raw data that's been kind of indexed and searchable. So now if I go to my dashboard, I have 4,256 hits. I'm crossing my fingers because the Raspberry Pi wasn't working this morning due to firewall restrictions, so hopefully this application kind of respects us. But more or less, this is something that comes out of the box with Solar. So if I click search, there we go. 8,000 records. So it updated in real time. So when this is actually enabled to stream in real time, you can see the information being persisted to the dashboard in real time. And what I've done here is, we're managing one device, so I'm querying. So a business user might be querying for a particular device ID. I might have multiple device IDs. But what I've done here is just one device, but you can think about it as having supporting multiple devices. And so you can build tables on the bottom of the actual dashboard, which show you the raw data from the actual devices. Doesn't necessarily just have to be temperature and humidity. It can be kind of whatever binary you're more or less grabbing from the ecosystem. But Kabana is just a great way that I can visualize my data, right? So I can have more or less frequency as the results are coming in. I can have more or less a sunburst to see. In California, I have 8,000 hits and the temperature was 82 degrees. In Carlsbad, in that same city, it's going to be 8,400 hits and the temperature was 82.4 degrees, right? So all these rich kind of visualizations and features that I actually get from Banana. Okay. And then last thing I kind of want to show you guys is if I did actually want to stick this into HDFS, there's a put HDFS processor that we can use. So I can put it into a distributed storage like HDFS, or if I want to put it into S3, right? We support S3 as well. So I can put S3 object. For anybody who doesn't know, S3 is more or less an object storage system in the cloud that allows you to put files into there, right? HDFS is going to be block storage, so it would be files, distributed files on premise when you're actually running your applications. And then Kafka is going to be a distributed pub sub system, right? So, okay. That's more or less all I have. You can see here, I have some other stuff as well. I'm not going to get into that, but these are the processor groups, right? So if I wanted to logically organize kind of my flows, I can stick them into processor groups. So that's a simple example. We can go to Q&A afterwards. I'm sure you guys have a bunch of questions. But I'm going to get back to more or less the demonstration. Awesome. So I showed you, right, one aspect of the three tenets to HDF, that being flow-based management. I gave you an example, streaming something from an edge device into Minify and what you could hypothetically do with that. The next thing you kind of ask yourself from an enterprise level is how do we administer and secure it, right? And we administer it using Mbari. So if you haven't heard of Mbari, it's effectively a project that just makes installing Hadoop-related services much simpler. And it's also an interface where I can configure all those services to work with one another from one location. I don't have to actually go into a conf directory within the CLI and edit files. I can do that from Mbari. Something that's also important is going to be Schema Registry. And Schema Registry is important because anybody who's a developer, anytime you have data coming in, you don't want to just necessarily trust it as being valid data. So the Schema Registry is more or less going to be a way not only to have a centralized place to keep your schema as the schema evolves or the record evolves through your application, but it's also a way to ensure security, right? So if a malicious payload gets in there somehow, it hits the schema, it's just not going to go anywhere because it's not validated by the actual Schema Registry. And then Minify registry. So a lot of our customers were asking or requesting for a way to take what I just showed you, those flows, and version control them, stick them into Git, and have an out-of-the-box way to do that. And we've since encompassed that into actual HDF and into Minify. So it makes the whole overall CI/CD, continuous integration, continuous development kind of cycle much easier to maintain as an overall application developer, particularly when you're building those streaming applications. So this is going to be an example of Embari and also Ranger. So Ranger is our way to provide securities, and it's role-based security. So effectively what you'd have users on the platform. They'd be in your corporate AD or your corporate LDAP, and Ranger would sync to that. And then subsequently what I could do as an administrator is say, hey, I only want John to be able to access Storm or Kafka, and I'd come in here and I'd apply a policy to Kafka or Storm and create one and say that, hey, John is only allowed to go to Kafka and Storm, which sounds trivial, but anybody who's worked in kind of big data or at the ACL level with HDFS or Hadoop or Yarn, this just makes the overall process so much easier because you actually have an interface to be able to do this stuff from. And then like I've already mentioned, so Apache Registry. So when you're in your actual processor, if you actually have registry enabled, you can start version control in your flows. So the developer, that's brilliant because when I have a flow that I'm building, and let's say I'm not sure about my consumer, who's going to actually be digesting my data, and I want to go back in time to code I previously wrote. Well, before what I had to do is what I showed you with the template. I literally had to download a template and save it somewhere. I no longer have to do that. I can save the template into Git kind of out of the box. And then also something is variable registry. So anybody who's written applications kind of knows that having macros at the top of your script that you're going to change depending on the context of how you're deploying the application, it's the same thing, right? So you have a macro that lives somewhere within the context of the processor that you can use over and over again, so that when you're sharing the actual flows between teams, you have kind of a convenient way to actually create host names, for example. And then Schema Registry, right, which is important for both data governance and operational efficiency. Why? Well, again, so none of the kind of data that's coming into your system should be declared as safe. So having kind of a centralized registry to not only understand the schema, but kind of govern the way that flows are interacting with one schema, that's something that Schema Registry provides. And then obviously operational efficiency. So some of these schemas are huge. They're not just as simple as I showed you. I have one customer who has 1,500 columns and one table, and that's just a table. So some of these schemas can get quite large and complex, and so having a central place to monitor those is extremely important. And last but not least, kind of the streaming portion of this. So I'm going to talk about Kafka at a very high level, kind of what we've done to help teams out that are using Kafka right now. And then I'll talk about Storm versus Spark Streaming, when you would use Storm over Spark Streaming. So simply put, what is Kafka? It's going to be a distributed pub-sub system. And you have a notion of producers and consumers. So producers are actually going to be publishing Kafka logic into Kafka. And the logic is encapsulated in what's known as a topic. So your topic is going to be effectively the host that you're listening to within Kafka, so that when I'm writing an application, my consumer, something that's going to consume it, let's say it's a Spark application, all I'd have to do is list the Kafka topic and it as an actual consumer, and it will be pulling data from the actual topic, right? But long story short, it was developed by LinkedIn. It's a great tool to reliably transfer data from point A to point B, right? And that's why we support it. But this is new. It's quite brilliant. And again, some of this stuff sounds trivial. You have to kind of work within the context of being a developer and using Kafka. And right now, if you're managing kind of Kafka topics and Kafka queues, it's a real big pain in the butt to understand kind of from a statistical level and a metrics level what's going on in the queue. You have to have some custom UIs you want to build yourself, or you have to set up some JMX type messaging that you're pulling kind of schematics from Kafka, right? But more or less too is you have this notion of a CLI client tool. So here what I'm doing is I'm actually, as a developer, I'm trying to see I have a cryptocurrency Minify data channel, and I just want to make sure the data is actually in there. So if you're a Kafka person, you've probably done this before, where you're just dumping the channel into the console. Well, what we've done at Hortonworks is developed what's known as Streaming Manager. So now you have a really rich interface that you can go to, and you can manage multiple topics, right? So that's what you're seeing here. You're seeing multiple topics. Moreover, you can start to see choke points. So if one of your downstream consumers has too many, I don't know, partitions going into one consumer, let's say, and it's getting overwhelmed, well, instead of just having the application break or me not knowing, I'd have to go look at the actual system process. I can now actually go to a UI and view that information. So as a Kafka developer, that's absolutely brilliant. It's really convenient to actually have that user interface. And then Storm. So Storm is going to be a distributed fault-tolerant service that supports streams of data. And so what I mean by that is you have several components in Storm, right? So you have your more or less your spout. That's a nomenclature in Storm that will be capturing data from an external system, like Kafka, HBase, Hive, HDFS, or AWS Kinesis, which is AWS's streaming service. And then you're going to have a notion of a bolt. And your bolt is going to be your transformations. So things like, when I say transformation, I mean like filtering, mapping, flat mapping, aggregating, reduce, count, right? Maybe you're running some statistics on it. And then the bolt can also be used to do an action. So you can write back to storage system, HBase, Hive, and Druid. You would use Storm when you needed to have so much data that you needed distributed computation, right? Otherwise, you can just use a local application. But Storm and things like Spark and things that are in the Hadoop ecosystem are generally meant to scale to terabytes or petabytes worth of data, right? Some of my largest customers have 1,600 nodes. It's a lot of nodes, right? But again, yeah, it's generally used to just processing streams. And so another question I get a lot too is where does this compete with Spark streaming? And why do we still support it? So if you need sub-second latency, you need to use Storm. Okay? Spark does not support sub-second latency yet right now. It only supports latency between 1 and 10 seconds. So it's considered micro-batching. Okay, we call it in the industry micro-batching. So you would use Storm if you need sub-second latency. Otherwise, you could use Spark. A lot of the reason why there's such enthusiasm over Spark is if you're a developer, it has a lot of very rich and easy to understand APIs, right? The libraries that come out of Spark are very easy to work with. The methods that come out of the box are awesome as a data scientist or as a data engineer to work with. So that's more or less the reason why you would choose Spark over Storm. But for the most part, if you're doing very intense operations at sub-second latency, you'd be using Storm. Next, I'm going to get to questions. I think I'm running a little early because the demo was kind of cut short, so we can do questions. Talk about from one developer to another. I really recommend that you check out our Hortonworks community connection. It's effectively our answer to Stack Overflow for big data. So you have questions on big data, how do I run this service, why is this Spark job not running? I can come to Hortonworks community connection and post a question and have someone answer it, right? So it's exactly like Stack Overflow. Moreover, you can do the same thing that I kind of just demonstrated within the context of a VM, right? So we have two sandboxes, and we have a sandbox here that I've included for HDF tutorials that you guys can get your hands on as developers and more or less kind of experience what I just showed you and experience the simplicity. I showed you a very simple example. It's not super complex. So hopefully this was advantageous for you guys and educational. And I'll be free after the lecture and after at the booth if you guys have specific use case questions or questions. I'm also joined by a good friend of mine, Andy Lopresto. He's an Apache Minify core committer. So it means he actually contributes code to Minify for our distributions. So he's a wealth of knowledge as well. And without further ado, questions? Yes?
What were some of the roadblocks you ran into or things that you found you couldn't do that you wanted to do?
Well, I wanted to show you me actually logging into my, logging into my Raspberry Pi. But there's things on the Raspberry Pi that I would be doing that I didn't get a chance to show you, like the bootstrap sequence to actually building the Minify process and actually having it push it site to site to Minify. Unfortunately, I didn't have an opportunity to do that.
I guess I meant more on the tool side. Is everything basically fully functional, everything you want to be able to do? You demonstrate everything, or something called?
Yes, more or less, yeah. That's all I got. Yes. What's that? You generally have a cluster of it, and it's, so the way you would size Minify is by I/O, right? So you size it by cores, depending on the complexity of your job. I haven't seen anything over 3 kind of nodes, but yeah, we'd have to kind of measure out what you need, yeah. But generally, you'd have a cluster, yeah.
Right, so if you offload smart jobs to the EMR cluster, get notified back, like using
I don't know if we have a processor out of the box that would allow you just to dump it into EMR, but we do have we can build you one. See, that's the beautiful thing about Minify, and I guess I didn't have a lot of developers in the room. I kind of got a lot of blank stares. But the beautiful thing about Minify is I can build a custom processor that abstracts the way that the Java we've already built. So I could build a custom processor that dumps in the EMR, so be it. But hypothetically, you'd probably just dump it in S3, and then from EMR, run it over S3.
something like go to S3, put SNS to the EMR cluster, saying go pick up that file, do what you gotta do with it kind of situation.
Yes, you can also put the queuing mechanism in a Minify. So you can put the message from Minify. Yeah, whereby you can do that, yeah.
And Flink is not a problem I saw on the sides,
Yeah, I believe, well, I can check right now. Yeah, I think there's a processor that you just dump to Flink, yeah. Flink's brilliant, yeah. Flink's absolutely brilliant, yeah. So the slides should be on the website. They were posted on the website, yeah. Big Data Day LA, yeah. Yeah, no worries, man.
Really well.
Yeah, thank you, man.
Really good development ideas there.
I appreciate it. Oh, thanks, man. Appreciate that. Sometimes I feel like it's a little bit